before the break, so I kind of don't really remember what I did exactly. So kind of bear with me. The problem was you're a mechanical engineer and you created a ball that dropped on every bounce to a height of 1/2n. You dropped the ball from an initial height of 1 foot, and the summation of the bounces after the first drop was 1/2 plus 1/4 plus 1/6 and so on. So I took the limit of the height that it bounced, and the bottom goes to infinity, so the whole thing goes to infinity. So that's the summation of this is eventually going to go to 0. And then I used the formula, the A over 1R, and plugged in the 1/2, which was that should be 1. The first bounce, and the R, which I don't remember where I got that from, but it came out to be 1. And then I added the initial drop, so 1 plus 1 equals 2 feet traveled.
Draw me a picture of this bouncing ball. Can you do that? A nice floor somewhere and a 1 foot up. Give up on that marker. Throw that one in the trash. It's gone. Kind of like your tuition. So here's this ball. It's 1 foot up, right?
Mm-hmm.
So everybody help them out here and figure out how far this ball is going to travel.
Okay. Cool.
So it goes down, right?
Yes.
Don't let it go straight down. Pretend it's bouncing. Yeah, so it doesn't. So we can count. Kind of have it going in that. Yeah, there we go. Comes down and it hits. Put it at the bottom. Now, how far is it traveling?
That's 1 foot.
1 foot, right?
Right.
So put a 1. Now it bounces back up. How high does it bounce?
Half of that, so I'm half.
All right, this ball bounces exactly half the height every time. Make sense?
Yeah.
So it goes up to a half, then what happens? It comes back down, right? Now when it gets back down to the bottom, how far is it traveling?
1/2.
Another half?
Okay.
Now you told me the answer was 2 feet. It looks, if it bounces again, I think it's going to go farther than 2 feet, right?
Right.
Everybody understand the question? That's an interesting problem, isn't it? Now this sounds like a simple task to give a mechanical engineer, right? Design me a ball. What determines how high a ball bounces? What is it that determines that? Pardon? You guys are going to be engineers.
Elasticity.
Yeah. How soft it is, the density it is, the material it's made out of. The long and short is the coefficient of elasticity is the fancy physics word for that. It also depends what you're bouncing on, right? A mattress or a diamond platform. You're going to bounce different because the coefficient of elasticity of the thing you bounce it off of also matters, right? So in real life, this is a hard enough problem that we're honing it down to its essence. I sent you out to the shop and I said, come back with a super ball that if I bounce it from 1 foot, it'll come back up to a 1/2 foot. And then if it bounces again, it's going to come back up to what? 1/4. And then it's going to go again up to an 8, right? Mm-hmm.
Wouldn't it be 1/4? Or is it 1 plus 1/2?
Well, it starts at 1 foot, right? It bounces down. It comes back up 1/2 foot, right? And then back 1/2 foot. So he's not done yet. What's the next thing? It's now at, was it?
1/4.
Right, 1/4 plus another 1/4, right? Plus an 8 plus an 8. Now I promise you, this is one of those problems that's worth working on. You're going to be surprised by the answer. You're going to be surprised by the answer. Because this is a perfectly logical thing to give a mechanical engineer. Just go design me a ball that bounces half the height. How hard can that be, right? I mean, I got Super Balls, I think bounce higher than that. Right? Yeah, everybody guy had a Super Ball when he was a kid, right? My kid got 12 of them. Prized possession was a glow in the dark. Okay, so there's more to be thought about on this one. 281 Scorpio.